You're welcome, honey. Just set it right on my desk. It's awesome. Thank you. All right, so if I take a look at 49, all right, if I take a look at 49, the directions were express each rate in miles per hour. So I want to get the rate to miles per hour. So what I've started with is 270 feet in 10.8 minutes. All right. So the conversion factors I need to go from minutes to hours. So I know there are 60 minutes in 1 hour. And I need to go from feet to miles. There's 5,280 feet in 1 mile. So I'm going to go ahead and set that given up as a rate. All right, it's distance over time, because that's always what rates are. So I have 270 feet over 10.8 minutes. Peter, did you start with your feet first or your minutes first? Or what would you like me to start with? Did you start with your feet first or your minutes first? Minutes. So I'm going to go from minutes to hours. So I'm going to multiply this by my conversion factor. I need my 60 minutes in my numerator, so my minutes divide out, which means my hours in my denominator. If you don't have this, you're writing this down now. So everyone's paying attention to number 49 right now. Chris, are you working on 49 with me? Yeah. Okay. All right. So I end up with 270 times 60. That gives me 16,200. My units in my numerator are feet. Divided by 10.8 times 1 hour, which is 10.8 hours. All right, so now I'm going to change my feet to miles. I'm going to multiply this by 1 mile over 5,280 feet, because I need my feet to divide out. So I end up with 5,280 times 10.8. So my denominator is going to end up being 57,024 hours. And my numerator is 16,200 miles. So now I'm going to go ahead and do that division. So 16,200 divided by 57024. And I end up, if I do this right, 0.28 miles per hour, or approximately 0.3 miles per hour. I would have taken either one of those. And I hope that was our answer. What else can I do for you guys? No other questions? Nick, what do you got? 28. Let's take a look at 28. All right, 28 said I have 7 over n is equal to 35 over 88. Okay, I expect you, Chris, sit up, put your calculator on your desk and listen to what we're doing. I expect you guys always to use cross multiplication to solve proportions. Always. Now, 35 and 88, I don't believe they have a common factor, so I'm going to go ahead and just do my cross multiplication. So I am going to multiply my numerator of 7 by my denominator of 88, and I'm going to set that equal to my numerator of 35 times my denominator of n. So now 7 times 88 is going to give me 616 is equal to the 35n. I'm going to divide each side by 35. And I end up with n is equal to 17.6. They probably may have written this as 17 2/3. I would take 17.6. That's fine with me. Jacob. Nick, does that help you? Excellent. Jacob, what can I do, sweetie? Yep, let's take a look at 37. 37 had k plus 5 divided by 10 is equal to k minus 12 divided by 9. All right, Jack helped me remember something that I didn't tell you guys yesterday that sometimes I forget to tell you. I cannot divide out common factors between the 10 and the 5. Why do you suppose that is? Why do you suppose I cannot divide out common factors between the 10 and the 5? Matthew? Yeah, I mean, that 5 is being added to that k. I can't do that. Same thing with this 12 and this 9. Because that 5 is in an expression with that variable, I can't divide out common factors with that denominator. Is that what you did? Yep. So I would start this by 9 times the quantity of k plus 5 is equal to 10 times the quantity of k minus 12, and then you guys would solve that. Does anyone want me to solve that? Peter, you want me to solve that? Okay. So I'm going to do my distributive property here. So I have 9k plus 45 is equal to 10k minus 120. I'm going to do plus a negative. I'm going to add a negative 9k to both sides because I like having my variable, the coefficient, positive. So I have 45 is equal to 1k plus a negative 120. I'm going to add 120 to both sides, and I end up with k is equal to 165. What other questions do you guys have? Blythe? 51? Okay. So if I take a look at 51, 51 is a story problem. It says human hair grows at a rate of 0.35 millimeters per day. So hair grows 0.35 millimeters per day. All right. Then it says, how much does it grow in 30 days? Okay. So, Blythe, this is a proportions problem. I have two different situations talking about the amount of growth and the number of days. I have 1 day. So here I have 1 day is 0.35 millimeters. And then the second one is I have 30 days. And I don't know how many millimeters. This is a proportions problem. All right, so I'm going to write 0.35 millimeters over 1 day is equal to x millimeters over 30 days. I highly recommend you leave your units on these so you know you've lined those up properly. So are you cool with that? Now I'm just going to do my cross multiplication. I have 1x is equal to 0.35 times 30. All right, so I have 0.35 times 30, and that gives me x is equal to 10.5, and this was what was missing was millimeters, so 10.5 millimeters. So I would write after 30 days, the hair grew 10.5 millimeters. Don't forget to state your answer as a sentence. Colin, you're paying attention to what we are doing. Not marking off the days until whatever. All right, put this away, get your notes out. All right, you guys need your rulers. As you're getting your stuff out, you need your rulers or protractors. You guys all should have a ruler or protractor in your stuff. Today is 12/12. We are moving on to 4.2. All right, we are talking about proportions and similar figures. We're talking about proportions and similar figures. You guys need your rulers. Please get those out. Okay. One of the things I need to remind you of is corresponding parts. All right. Corresponding parts, these are going to be sides and angles. How many of you guys kind of remember us talking a little bit about this? All right. So, corresponding sides, these are sides located in the same location in their respective figure. We're going to talk about what that means in a second. Corresponding angles is the same thing but with angles. Corresponding angles, these are angles located in the same location and their respective figures. So corresponding sides and corresponding angles, they are sides or angles located in exactly the same location in their respective figures. Right? Let's talk about similar figures, because I need to get this vocabulary kind of out there so we can remember how we can find missing sides. Similar figures are two or more figures. Usually we're just going to deal with two or more figures that are exactly the same shape but not the same size. They're exactly the same shape, but they're not the same size. Yes? So similar figures are exactly the same shape, but not the same size. All right, so let's take a look at what corresponding angles and corresponding sides would look like. Dude, you got to keep up with us. Oh, you're good. Okay. So I want you to draw two right triangles. We can do triangles, we can do rectangles, it's really any polygon. So there is one of my right triangles, and then I'm going to draw a smaller one that's the same shape. So I'm going to say A, B, C, and then X, Y, Z. So I'm going to say triangle ABC. One squiggly line means similar to. So triangle ABC is similar to. So that squiggly line means similar to. Triangle. Now, the way that we list these is very important. What angle is in exactly the same location in the smaller triangle as A? Or what is A's corresponding angle? Jacob? X. Since A was listed in our big triangle, its corresponding angle is going to be listed first in the other triangle. B is the one in the middle for this listing. What is B's corresponding angle? Serena? Y. And then Z goes with C. So the order in which these are listed when they give them to you is in the order of corresponding angles. Are you guys good with this? Okay. So in similar figures, corresponding angles have the same measure. Corresponding angles have the same measure when we have similar triangles or similar shapes. Okay. What is AB's corresponding side? So I'm going to write here our corresponding sides. So if I write AB, who is AB's corresponding side? Victoria? XY. Because they're in the same location. If you want to draw arrows, I think they're helpful. So remember, to show a side, we put a little line above the two letters. So side AB and side XY. All right, somebody give me another set of corresponding sides. Colin? BC and YZ. All right, someone give me the last set of corresponding sides. Chris? Excellent. AC and XC. The order in which you write the letters does not matter. So that could be XZ or ZX. It doesn't matter. Nick? I suppose we could. I just use an arrow, just showing that they're corresponding. So the thing about corresponding sides, the ratios of corresponding sides are equal. The ratio of corresponding sides are equal. So what that means is I can set up proportions using corresponding sides. We can set up proportions using corresponding sides. That's the big thing that comes out of this. So if I knew the measurement of all but one of the sides in one of the triangles, I could find that side using proportions, and that's what we're going to do right now. All right, so corresponding sides, the ratios of corresponding sides are equal to each other. So we can set up proportions using corresponding sides. How many of you guys remember this from last year? Okay, so let's do one of these. Who needs to see what's up there? You guys cool? Who needs to see what's up there? Okay, so let's practice one of these. Okay, so draw these two triangles. I do expect you to be using your rulers, particularly in your homework as well. So I want to see you drawing your figures using your ruler. Don't be lazy. And they should look like exactly the same shape, just one's bigger than the other. So do the best you can on those. So A, B, C, D, F, E. All right, our given, other than the drawing, our given is triangle ABC is similar to triangle DFE. Now, one of the things I also want to point out to you, not only does this listing show us corresponding angles, it also shows us corresponding sides. So AB is listed first. Who is AB's corresponding side, according to my drawing? Because some of these, they're going to be turned around differently, and it might be hard to figure out the corresponding sides. Who is AB's corresponding side? Blythe? DF. These are corresponding. And they both are the first two letters in each list. How many of you guys noticed that? All right. BC is listed the last two letters. Who is BC's corresponding side based on your drawings? Peter? FE. And FE are the last two letters in our list. All right? And that means that DE and AC are corresponding sides, and they're both the first and the last and the first and the last. So if you get to shapes and you look at them and you're like, I can't figure out what the corresponding sides are because one's rotated, use the list that they give you. Okay, so I want to tell you that AC is 21 centimeters. CB is 18 centimeters. BC is 15 centimeters. In the other shape, DF is 10 centimeters, and ED, I don't know. And I want to find X, or DE. Okay, so what you need to do is you need to find a set of corresponding sides you know both measurements for. So find a set of corresponding sides that you know both of the measurements for. Which set of corresponding sides do you know both of the measurements for? Jacob? Yeah, I know AB and DF. I know this set right here. This is going to be your known fraction. That is going to be your known fraction. So I'm going to go ahead and set that up. So you don't have to use the letters. I am for this one just so you can see this. So I have AB over DF equals. Then what you're going to do is you're going to find the missing side and its corresponding side. So the missing side is DE. Who is DE's corresponding side? Who is DE's corresponding side? Kaylee? AC. So that one is going to help us. This is going to be our unknown fraction. So AB was from my big one. AC must also be in the same location. So both of these came from the big triangle. Our denominator is going to be that DE, and both of my denominators came from the small triangle. It's not working. I don't know why. Sorry. Someone found that out yesterday. All right, so now I'm going to set up my values. So I have 15 over 10. 15 came from my big triangle. 10 came from my little triangle. Their corresponding sides is equal to, well, AC is 21. DE is my X. There's my proportion. Chris, you look defeated already. Why do you look defeated already? So did you take the initiative and go ahead of us and do it? Oh. Oh, no, yeah, you've got to write the same way. Do you understand how to fix that confusion? Okay. So the key to this is finding a set of corresponding sides you know both measurements for, and then figuring out the corresponding sides where one of them is missing. And then when you write your ratio, or you write your proportion, it does not matter which go in the numerator, which go in the denominator, as long as you are consistent. So for my known one, my big triangle went in my numerator. So that means my big triangle has to go in my numerator for my unknown as well. You have to be consistent. Now we do our cross multiplication. So I have 10 times 21 is equal to 15x. So I have 210 is equal to 15x. Divide both sides by 15, and I believe x is equal to 14, and this would be centimeters. Questions? I'm not done. Funny how I'm the one that should let you out, right?
Yeah.
Questions on this before I give you another one? Peter, what's up? I'm looking at what they gave me in the book, and that's what the book tells us. So I have 15 over 10, 21 over x. I have 21 times, that's right. Yep. All right, I want you guys to do this one. You have to draw them. You're doing this additional example right here. So there you go. Everyone do that, please. Start with drawing it. Come on, Andrew. Start with drawing it. Make sure you label it properly, Chris. And the rest of you. Use your ruler for drawing. Use your grid lines for drawing. No shortcuts. Can you see those? Well, get up and go look at them. Bring your glasses. Yeah, I got that. I don't mind if you need to get up. When you're done, just put your pencil down so I know you're finished. So here is the drawing, in case you couldn't see it and you don't have it. So there's the drawing. Again, you don't have to set the proportion up with your side letters. You can go ahead and set them up with the numbers, but be very careful. All right, so somebody set up your proportion for me. Serena, go ahead. So you did AB over, is this an E or a C? This should be an E right here. So this is D, E, F, A, B, C. So AB over DE, right, is equal to what? EF. Okay. All right, so go ahead and put your numbers in. No. I have 6 times x is equal to 8 times 9. I have to see that step. Okay. So 12 millimeters. How many of you guys set up your proportions a little different than that? Colin, what'd you do? Okay, I'm just asking this. How many of you guys did a different proportion than this? Matthew? So tell me what you had. Okay, so that's exactly the same proportion. Could I have done 8 over x is equal to 6 over 9? How many of you guys agree I could have done that? Yeah. The order does not matter which one you put in which location. All right, you guys got to go. Go ahead. Colin, what's up?